And the last example of a horizontal circle is for a vehicle rounding a bend on a horizontal road and on a bank track. Now, if a car, for example, makes a turn on a horizontal road, let's say you are driving in a roundabout on a horizontal surface, what will happen is the two forces acting will be a normal reaction force upwards and your weight downwards. And so what will happen is these two forces will cancel each other because there's no vertical motion. So what force actually exists to provide the centripetal force is actually a frictional force. So here your frictional force will provide the centripetal force. So since your centripetal force is only provided by friction, if the car suddenly hits a patch of water or oil and it loses friction, what will happen is the car will not be able to travel in a straight line. It will skid tangent to the circle at that point. Now, which is why in most racing events like bicycle racing in a velodrome or IndyCar racing in US, what they will have is a bank track. So what is the function of a bank track? That means a track that is banked at an angle. Because when the track is banked at the angle, the normal reaction force will now be 90 degrees to the surface, so it is no longer vertical. And if it's no longer vertical, we can resolve the normal reaction force to two components, which is your horizontal and your vertical components. So the horizontal component of your normal reaction force now can help to provide the centripetal force. So rather than just relying on the frictional force, now you can have your horizontal component of your normal reaction force to help produce or provide more centripetal force, so you are able to travel faster on a bank track without slipping off. All right, so we can look at the forces here. So if this angle is theta, all right, so we can find out the another angle which is theta. So what will happen is if we were to draw the angle theta here, all right, this will also be angle theta and this will also be angle theta. So for r cos theta will now balance the weight, all right, and your r sin theta will now be able to provide the centripetal force that enables you to move in a circle. So what is the purpose of the bank track? Is so that the car is able to move faster. Now, and one thing about frictional force which we need to mention here is that frictional force is a dynamic force. That means it can change. It doesn't mean that when the car is traveling at any speed, the frictional force is the same when it turns in a roundabout. Now, your frictional force will be able to increase to whatever value that you need to produce a centripetal force, but up to only a certain maximum value. Meaning to say, if let's say the car is turning slowly, so the centripetal force needed is very slow, then the frictional force will be provided just enough to meet or provide the centripetal force. But if let's say the car is starting to move faster around the bend, then you need a higher centripetal force, so then the frictional force will increase to meet that need. Now, this will keep happening. That means the faster you travel, the higher the frictional force until a certain limit. All right. So after that limit, when you try to travel faster, too fast, turn around a bend or drive in a roundabout, what will happen is the frictional force will no longer be able to provide the centripetal force, and then the car will skid off the track. So do remember that frictional force is not a fixed value. The frictional force can increase up to a certain maximum value when you're talking about circular motion.